Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sarafika binti Mafakrudin. My matrix number is 33DCE 21F1019. I'm from DCE 2A. Today I'm going to present Tensile test on Marsden experiment in virtual lab. Alright. First, the objective to study the mechanical properties of Marsden specimen under tension load. Apparatus used: universal testing machine, dial indicator, extensometer, scale, and vernier caliper. Alright, this is the what we showed the Tensile test in virtual lab. As you can see, this is the machine, and next we can do. Alright, first and foremost, step 1, measure the interior diameter of the tension test sample in two perpendicular direct using the vernier caliper. Alright, tap over here and it will measure the okay, the diameter we got 12.82 millimeter. Average interior diameter is 12.82 millimeter. Okay, press the ruler over here and measure the specimen. Measure the length of the specimen between the grip using a scale. Length of specimen between grips 192 millimeter. Next step, punch the mark made a distance of 2.5 diameter. Okay, tap over here. One by one, we need to tap. Okay, we have already made a hole on the specimen. Next, we should press the arrow and insert the specimen into the position and mount extensometer on the specimen. We need to drag the specimen over here and we need to put here. Okay, reading the dials A and B of the extensometer adjust to 0. Okay, from 0, okay, both of extensor must be 0. Okay, at least count extensor equal 0.01 millimeter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nufarisha binti Muhammad Fairuz and my matrix number is 33DCE21F1017. Today I want to continue for step 6 is experiment is conducted. Load extenential readings are read at irregular intervals of load up to the yield point. Ivory scale readings are not until the specimen failure. Okay. This is the result, the data of the experiment. Okay, let's continue. Step 7, the graph. Okay, this is the graph. The load vs ivory scale reading. The part C of X is ivory scale reading in millimeter, and part CY is load in kilonewton. Alright. This is the second graph, or on the second graph, the part C of X is S tensometer reading in div, and the part CY is load in kilonewton. Let's see view slope. Okay, the slope in the graph load vs S tensometer reading is 2.27. Okay, step 9. Join the piece of the test sample and measure the diameter at the neck of the specimen. Okay, press the final diameter is 7.86 mm. Step 10. Measure the final length between 3 punch marks. Final length between the punch mark is 8.5 mm. For the step 7 is observation and calculation. For the calculation, we should calculate the yield stress, tensile strength, modulus of elasticity, percentage of elongation, and percentage reduction in area. For the first, yield stress. Before we find the yield stress, we should find the point of yield stress in the graph. So our point in yield stress is 43 kilonewton, and change to newton is 43,000. Okay. The formula for the yield stress is load in kilonewton, or the point of yield stress, divided by original CS area in millimeter per second. Okay, so original area in millimeter per second is 129.02. So the yield stress we can get 323.28. Second, we should find the tensile stress in the formula. Before that, we should find the point of the tensile stress in the graph. So, the point of tensile stress in the graph is 49 kilonewton. Change to newton is 49,000. Okay. The formula for the tensile stress is unlimited load, or the point of tensile stress divided by original CS area in millimeter per second. So when we divide it, we can get the 379.79. Okay, for the third is modulus of elasticity. So the formula is slope times 1 per least count times gauge length per original CS in millimeter per second. So the value of slopes is 2.27, and the value of the least count is 0.01. The value of gauge length is 120. So we use the formula, and we can get the modulus of elasticity is 211.13. Okay, for the fourth is percentage elongation, and the formula is final length between the 3 punch minus punch mark times 2 divided by punch mark times 2 times 100%. So the value of final length between the three punch is 85, and the value of punch mark is 31.42. Okay, so we use the formula, we can get the percentage elimination is 35.26. The last one is percentage reduction in area, and the formula is original CS minus final area of CS divided by original CS times 100%. Okay, the value of original CS is 129.02, and the value of final area of CS is 48.5. Okay, we use the formula and we can get and the value of percentage reduction in area 62.41. Okay, so we get all the calculation and we can check the result. So this is our lab for the result and no percentage error. And that's all for our group. Thank you for watching and listening it.